Okay, can. Let's try. Okay, come. Exit past 7.2. Okay, let's push on a bit more. Okay, given 3 points over there, show that PQ and QR are perpendicular. So number 1. Now, when we talk about perpendicular lines, what's the property that we can use? M1 times M2 is -1. Okay, so we need to show that one to say that the things are perpendicular. So let's take a look at PQ and QR. So we look for gradient of PQ first. So what's the gradient of PQ? Y2 minus Y1, X2 minus X1. So this will be -6/8. So -3/4. Okay. Then we look for the gradient of QR. So same thing, Y2 minus Y1, X2 minus X1. Okay, take note of brackets. Okay, so we have -8/6. Which one? Positive? Okay, positive. This one is -4/3. Okay? So what we're going to do is to show perpendicular, right? We need to... Okay, because the conclusion is perpendicular, we need to multiply them and really test and see whether is it -1. So let's test gradient of PQ, gradient of QR. So what's the gradient of PQ? 3/4. What is the gradient of QR? -4/3. When you multiply these together, answer is -1. Okay, so therefore, because this happens, therefore, PQ is perpendicular to QR. Just like that. Okay, number 2, determine whether those two lines are perpendicular to each other. So let's call line 1, y equals to 2x minus 5. Let's call line 2, 2y plus x equals to 5. So rearrange this one, we have something like this. Okay? So over here, what is the first gradient? 2. What is the second gradient? -½ Okay, so let's test out our gradient and see. So let's try M1 and M2. So what is M1? M2 over here, when we multiply them together, they get -1. Okay, so let's say if it's not -1, now you can straight away add one more, not -1 behind. Okay, let's say if it's not. Okay, so because of that, the conclusion is the two lines are perpendicular, or both lines are perpendicular. Or you can put L1 perpendicular to L2 in symbols. Okay? Okay, question 3. So, the first skill is to know whether something is perpendicular or not. The second skill is to build an equation for the perpendicular line. So next one for question 3, we have this one. So from y equals to 3x minus 5. Okay, so the gradient is equals to 3. For the gradient for the first one is equals to 3. And then we need a new line, a perpendicular line. So for the perpendicular line, okay, and it's passing through 6, 3. Okay, we can make use of this one to look for the gradient. So for the perpendicular line, M1, M2 is -1. So the first gradient is 3, second gradient is M2. Okay, so we have the gradient for the perpendicular line, -1/3. So the equation of the line is going to be equals to y minus y1 is equals to m x minus x1. Okay, so I'm going to sub in the points, sub in my gradient. So here y is equals to -1/3 x plus 2 plus 3, so it's plus 5. Okay, mainly like that. Can? Any questions so far? Anything to ask? Same skills like the parallel line, just that now we need to do a little bit of change for the gradient. Okay? Okay, next one. Question 4. Question 4. The last one. Okay, question 4. So in the diagram over here, the line through 6, 3 is perpendicular to the line y equals to 3x minus 5. So got image over there, so very nice. Okay, let's say if there's no image like this one, you have to visualize on your own. Or you can just do it without any visualization. Otherwise, it will be very helpful to think of something like that. Okay, so number 4, find the equation of this perpendicular line. Okay, so how do we find the equation of this line? We will need the perpendicular gradient. We need a point, correct? So for the, from the original line, okay, you get the first gradient. So for the perpendicular line, okay, and this line is actually through which point? Through 6, 3. Okay, let's find the gradient over here. So gradient, okay, so m1, m2 is -1. So the first one is 3, means the second one will be -1/3. Okay, and because of that, the equation of the line is going to be equals to y minus y1 equals to mx minus x1. So we need the point 6 and 3 over here. So x is 6, y is 3. Okay. Same line. It's the same exact thing. Can. It's the same exact thing. Sure. Okay, so this is number 1. Okay, number 2. So given that the two lines intersect at point F, find the coordinates of F. So now we are looking for points of intersection. So when looking for points of intersection, what skill or what tool do we need? Two lines intersect at one point. We will need which skill? Substitution or elimination, your simultaneous equation. Okay, and because of that, we need to list down our two lines. So the first line is this. The second line is that. Okay, so how do you want to do? You want to sub or eliminate? What do you think? I will follow your order. Sub or eliminate? Sub? Okay. Right, correct. Okay, x is equals to 3. So from okay, so the coordinate of F is going to be 3 and 4. Okay? Okay, so because of that, we can find the perpendicular distance from A, which is actually this point over here, to the line y equals to 3x minus 5. So it means that this is y equals to 3x minus 5. A is over here, correct? So to find the perpendicular distance, okay, we have to make use of this point F over here which we just found. Okay, and we need the point A also. We need A and F. Okay, so over here for part 3, the perpendicular distance is equals to distance of AF. Okay, so what is the distance of AF? We need to make use of the formula. So x1. So x2 minus x1. So A and F are square y2 minus y1 square, and you square root. Okay, what is the content of this one? 3 square is 9 plus 1, 10. So square root of 10, is it like this? Okay? Can Okay, so Elisa, thank you. Okay?